Hey guys, how's it going? Welcome to the first part of getting started with NumPy. NumPy is an array creation and manipulation package present in Python, which is very popular among Python community. And it's mainly because with a growing need of data, we need a special kind of object that can take care of that thing and also could able to analyze and process this data with short span of time. And we have sequential databases like list, tuple, set, dictionary, etc., which could able to use as we could use that thing as an array, but that those things were not very efficient. And NumPy objects, which is ndarray, which we're going to see in a minute, is a specially designed array object which could able to process enormous amount of data with a very short span of time. With this, let's get started. So first thing first, let's get started with NumPy by installing it into the Python package. Essentially, you can install any package by using pip command. And if you want to know more about pip, then please follow my series on basics of Python where we have talked about pip in detail, or else you can go to my website defogging.com. Then you can go to the basics of Python course content. In the right hand section you will find all the content, course content. Then go to the pip command, Python pip command, and there you will find the detailed explanation what we have talked during that tutorials. And also you will find various way you can install any package by using pip. I will let you explore these two options by yourself. I will leave the link to in the description of the YouTube. But as of now, we will proceed, thinking that you have already know how to use pip. Now go to Python the command prompt and then type Python, then tag m, then pip install numpy. And mine is already being installed, that's why it's saying requirement already satisfied. If you are installing it for the first time, it will at the end it will throw you the message saying that successfully installed. Once you install successfully, go to Python by using by typing Python here, or just go to Python shell, and there you can write import numpy as np. Now this abbreviation NP is a general standard practice by lot many users. They put NumPy as NP, but you are free to choose any abbreviation you like. But go with the standard approach if you wish to share your code with other people. Now, if it is successfully installed, if you hit enter after import NumPy, it will run without an error. In that way, you will know it is installed successfully. There are actually many ways with which you can create a NumPy array, and in this section we will see few of the methods or mechanism with which you can create these arrays. NumPy's array class is called ndarray, and the main object of this class is a homogeneous multi-dimension array, and it is usually the elements of a table of elements containing numbers, but it could be extended to string as well. But you have to remember each element of this NumPy array has to be the same data type, which could be indexed by a positive integer, which we will see in the next lecture how you can slice and dice a NumPy array. But let's begin with how you can create a NumPy array. The first method which we're going to talk is to uh, convert this list and tuple by using a function of NumPy called array. So here we have imported the NumPy and put the abbreviation as NP, and also created a list which has 4 elements, and each element is of integer data type. Let's create an object A, which is a NumPy array object, and as we have discussed, let's say NP and then use the function called array, and then pass this list or tuple, in this case is list, as an argument to that function, and then here I can say print a. Now when I run it, you will see now this is a NumPy array. It's not a list anymore, which is X in this case, which is completely different than the NumPy array which we have created just here. Now coming back to the point of homogeneity, so each of the element of a NumPy array has to be the same data type. Now in the list, it is completely acceptable if the first element or one of the element is a different data type as compared to rest of the element. Now let's change the first element to 1.0, and then let's put this as an argument to a NumPy array function and then run it. You will see now X is the list here, where the first element is a float, the rest three are the integer data type. But when you convert into a NumPy array, all the elements of that NumPy array is a floating point number. So it forces list to convert or course into the higher data type format, which in this case integer to float. Now, though we have created the basics of array, let's first go through all the attribute which you can access it for a NumPy array. Then we will see the other example or other ways to create a NumPy array. So first, let's talk about the first attribute, which is ndim. Of course, we can actually access many other attributes, but we're going to discuss some of the few very important and crucial one. And as this is an attribute we are accessing, we don't need to pass open and close parentheses after the attribute name. So if you run it here, it will just print 1. So what this attribute does, it will return the number of axes or dimension of an array. Okay. Similarly, if we just now change, now this is like one dimension array. Now let's create a tuple of list of list, and let's pass 1, 2, 3 as a first element of the list, and the second element of the list is again a list which has 3 elements 4, 5, 6. Now if I will just go ahead and run it, you will see now the dimension has changed to 2, and if I will print the NumPy array, you will see it has 2 elements, 2 rows and 3 columns. That brings us to the third attributes, which is the second attribute, which is the shape. Now if I will just go ahead, this shape thing will always return a tuple, and this tuple will have integers indicating the size of array in each dimension. So this array has two rows, that's why it's 2, and then the column is 3, so that's why it's 3. And it always you will always get as a tuple as a return when you see the shape. Now the third point is size. So let's go here, or let's go back to our code, and here instead of shape, let's access the attribute size. Now what it will basically will do, it will return the total number of elements that present in the array. So in this case we have 6 elements, that's why it's returning 6. Or else you will first access the shape, which is 2, 3, and you can multiply each element within the tuple to get the size of the array of a NumPy array. And finally, the most crucial and important one would be the data type, which is dtype in short. And this attribute will return the data type of the NumPy array which we have created. Now we know that each element of the NumPy array is a similar or homogeneous data type in nature. That means this array which we have created has each element of int32 data type, and then the data type option available for NumPy is much more greater than the what it available for Python. I will not go through everything right now, but essentially you can you have 20 to 30 odd list of data types of NumPy array. But basically there are 5 numerical type representing Boolean, integer, unassigned integer, floating number, and complex number. Out of which 3 of them, which we generally use, Boolean, integer, and floating point number. But that's how you can access the data type. Now coming back to this point, before we move and see the further attributes, now if you wish to create an array with a specific data type, now you can do it by 2 ways. The first way is to specify the dtype here in the array function, and then pass the 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 data type which you wish to see for the NumPy array. Now if I will just run it and see, you will see now it changed to float 64, even though we are passing x, which is the list of list, and each element of the list is an integer data type. Doesn't matter because we are changing it to or coursing it to float 64. So that's why the data type is now being changed. The other way is to just to access np dot then float and then choose the data type which you wish to see for your NumPy array, then pass the list or tuple as an argument for this one. Now if I will run it, you will see it's still returning 64 because that's what we are accessing. Okay, that's how you can actually create a NumPy array with a specific data type. Now coming back to the remaining attribute, which is also very crucial, is called item size. Item size, and these attributes will return byte size of each element of within the array. Now if I will just say, sorry, it's not item, it's item size. Now if I will just run it, you will see it is 4. Oops, 8 because we have changed it to data type float. But if I change it to integer, it will return 4. Yes. So how you came to this number? Because this thing, which is the number represent after the data type, when you take that number and divide it by 8, you will find the item size of each element of that NumPy array. Now this NumPy array has 6 elements and each of having item size 4 because it's int 32, right? 32 by 8 is 4. So each element is 4 byte and we have 6 elements. So in total we have 24 byte size of that NumPy array A. Okay, now though we have seen various way to create the NumPy array using list and tuple, now we will see how you can create this NumPy array by using intrinsic NumPy array functions like arange, 1, 0, empty. So first let's talk about arange. To create a sequence of number, NumPy provide a function analogous to range that returns array instead of a list. So for that, let me delete everything till here and say np.arange, range, then here it takes 3 arguments: the starting point, which is 10, let's say, and the ending point, which is 30, let's say, and the increment value, which is, let's say, 5. Okay, now you can specify data type here as well, but as of now I don't want to see the data type, but here I will say print. Then if I will just go ahead and run it, you will see right now you get 10 to 30 with an increment value of 5. Okay. Similarly, you can also pass the floating number as well instead of an integer number. So here it's completely acceptable to pass 0.5 here. And then if you just run here, you will see each step is increased by 0.5 and each element of that NumPy array is float because we are increasing by a floating point rather than the integer number. But what's the problem here? When you use arange floating point with a floating point argument, it is generally not possible to predict the number of element obtained due to the finite floating point precision depending upon your computer size. Therefore, it is always advisable to use linspace instead of arange when you deal with a floating point number. So in that case, let's say np, and here you say line space, then here instead of let me change the number here, it also take 3 arguments. The first is the starting point, which I will, let's say, put 0, the end point, which is 2, let's say, and instead of the increment value, here I will pass the number of steps it should take. So let's say we want to see 9 steps, so from 0 to 2, 9 elements. Now if I will just go ahead and run it, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9 elements I need. That's why I'm using linspace. So these are the sequential number. But sometimes what happen, we generally know the shape, but we do not know which all element it present. I know it will confusing right now, but somebody told you, I know a metric size of 5 by 5, or let's say 4 by 3, and but we do not know the value as of now. Just create a placeholder for that thing. So for that we can use various NumPy function, and which we're going to discuss one by one. First one is called zeros. So this in built-in function will take or this method and NumPy array method takes the shape as an argument. So let's say I want 4 by 3 as a shape. So I'm saying create 0 matrix with 4 rows and 3 columns. So if I will go ahead and run it, you will see here uh, there are 4 zeros and 4 rows and 3 columns, and each of them you can see is a floating data type. So by default is float. If you wish to see it in other data type, you can specify here as a d type, as whatever you want. But I will not give you that example because we have already discussed that thing. The next thing which you're going to see is called 1. So similar to the zeros, if you wish to create 1 only, rows, 4 rows of 1, 4 rows of column, 3 rows of column, and each element has a value of 1, you can use one np.one function, and then it will create same thing. You can also pass a single, not a tuple, but rather a scalar value here, and in that way it will create a one-dimension array. So that's completely acceptable if you do not pass the tuple as argument for 1 or 0. Similar to 1 and zeros, ones and zeros, you can also use empty, and this also will take uh, the shape as an argument. So in that case we will have to pass the tuple here, and then if I will just go ahead and run it, you get this many this item as a return. And what it basically does, this function will create an array whose initial content is random and depend on the state of the memory. So it's completely arbitrary. So each time you run it, you will get probably a different result. So with that, let's talk about the last way with which you can create a NumPy array, and that is the uses of special library functions. So there are some libraries that can be used to generate array for special purpose, and it isn't possible for me to demonstrate all that example right here right now. But we're gonna stick to one of the example which is most commonly used, which is called random, and it can generate array of random value. So here instead of 1 0 or empty, I will say np.random and then random, and this again will take the the shape as an argument, which is a tuple. Let's say I want 1 row comma 3 columns of random values, and that I can pass here by to the print built-in function. In that way I can see which all result it's returning, and this will return a floating point number between 0 to 1, and result were continuous uniform. All these results are coming from the continuous uniform distribution. Let's pause it here. In the next tutorial we will see how you can slice this NumPy array using positive integer as an index. Till now, if you have any question, comments, please feel free to drop your questions comment in the comment section, or else thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.